Bismillahirrahmanirrahim. Assalamu alaikum. Can you hear me too? Can you see the slides also? Uh, Firstly, I have uploaded a project for you. Have you guys gone through that project statement? Any one of you have seen the project? So this project is the same as it is distributed for the other sections. Okay. So please download that project and please try to finish it as early as possible. The deadline for the project is 15th April. Okay. Project is very straightforward, very simple. You have to, your lab instructor will inshallah evaluate it. Okay. Uh, this this project is related to the sorting. Yes, yes, sorting algorithm. So what you have to do, you can take the algorithm from net, or even it is available on the slide for 204 as well as for maybe in some other slides. So you have to write a program and implement the sorting and test your algorithm for different number of data set and see how much time it take to sort the data with 1000 values, with 10,000 and with 100,000 elements. Now, how you will enter so much big data, and you should not be worried about that. You can use a random function and you can generate the random value for that declared array. So it will be automatically generated. Your task is only to record the time taken by these different algorithms on different data set, and then you have to write a report, a small report, in which the results will be compared with each other, and you will conclude your statement that which algorithm is performing better with your given data set. Is that clear? So it's very simple, straightforward: insertion sort, merge sort, and quick sort, I guess. And you have to just write down. You have not to design any new algorithm. All codes are already available, so you have to just write, and with different set of data, you have to compare it. No, there is no presentation. Just you have to write a report, 4-5 pages report about what data you have used and what is the outcome of that you have observed, how much time it is taking. Okay. So hopefully it will be completed by 15. You have sufficient, more than sufficient time to do this task. Yeah. Okay. So last time we started the discussion about the divide and conquer approach, and we see some discuss quickly through some algorithm which we have already studied in 204, and now we are moving to another example of divide and conquer, which is called multiplication of large integer. These examples which are included in this under this topic, they are not much significant. They are not improving the running time or the efficiency of the problem solving of the problem very significantly. But why we have included these examples? Because they are actually following divide and conquer approach in their design. Otherwise, efficiency wise, these algorithms are not much efficient. Okay. So if you want to multiply two numbers with each other, in which every number has n digit, how you will multiply it? For example, if you have two numbers, one is 324 and other is 175. When you multiply these two numbers, You have to multiply 5 with 324, then 7 with 324, then 1 into 324. So number of multiplication will be equal to how many multiplication you have to perform if you have to multiply these two numbers? No. If we have these two numbers, one number is 324, other number is 175. How many digit multiplication you have to perform? You have to perform 9 multiplication. Okay. So it means if every number has n digits, number of multiplication required will be equal to n into n, which is n square. Is that clear? This is the normal traditional way of multiplying the two numbers. But we can improve these number of multiplication by using divide and conquer approach. Now we will see how this divide and conquer approach is applicable to multiply two numbers having n digits. Starting with the simple example, and then we will, on the basis of this pattern, we will devise a formula. For example, if you have to multiply 23 with 14, can I write 23 equal to 2 into 10 raised power 1 plus 3 into 10 raised power 0? This is the place value of every digit in the number. I hope you are already familiar with this one. And similarly, 14 can be written as 1 into 10 plus 4 into 10 raised power 0. Is it clear? Now, if you multiply these two expressions with each other and simplify it, you will get this expression. Here you can see the expression will give you 2 into 1 into 10 raised power 2 plus into, yes, 2 into 4 plus 3 into 1 into 10 raised power 1 plus 3 into 4 into 10 raised power 0. So if you use the scientific notation for representing the number, then how many multiplication do you need? In this expression, you can observe that we have 1, 2, 3, and 4 multiplications. Is that clear? Which is very similar, which are equal to the number of multiplication required to multiply two numbers in a traditional way. Is that clear? On the same pattern, if we make a generic formula to multiply two numbers with two digits, whose digits are represented by A1, A0 and B1, B0. B0 represent the place value of 0. It is unit digit and it is unit and it is tens. Is it clear? So it is 10 raised power 0, then 10 raised power 1, and so on. Similarly, A is represented by two digits, which are A1 and A0. A0 is unit digit and A1 is tens digit. So if you multiply them together on the same pattern as you have seen in the previous slide, this expression can be written as C2. The second expression of two digits, that is represented by C1, and the last portion is represented by C0. Is that clear? So it is representing the general pattern, general formula to multiply two numbers having two digits in each. So here, if we further simplify how you will calculate these numbers, here you can observe that C2 can be calculated by multiplying A1 into B1. It means you have to multiply the tens digit of both number together. Then you have to multiply the second number, which is the unit digit with each other, and C1 can be rewritten as, rather than having three multiplications, two multiplications separately, we can rewrite it like this one: a1 plus a naught into b1 plus b naught. So if you rewrite these all values, how many multiplication do you need for a number of two digits? Now the number of multiplications will be, this is 1, this is 2, this is 3. Is that clear? So it means if you rewrite these formulas in this way, that C2 is calculated by multiplying the tens digit of the given number, and unit digits product is represented by C0, and C1 is calculated in this using this formula, then the number of multiplication required for two digit numbers will be reduced from 4 to 3. Is that clear? As I mentioned earlier, it is not much significant, but at least we have reduced the number of multiplication. And these number of multiplication, reduction in the multiplication number of multiplication will be more significant if we assume that we have n digits in one number. How it is significant? We will use the divide and conquer approach. And here, if you see this expression, what is the meaning of this expression? For example, if you have a number 4, 5, 6, 7, 8, let me take 4-digit number. One number is 4, 5, 6, 7, and the other number is 7, 8, 6, 4, for example. Now, having 4-digit number, if we reduce this number into such number which has half of the digits, can we rewrite it again? Can I write for 4567 like 4500 plus 67? Can I write it like this or not? So similarly, it means if I am taking one number A who has n digits, I can reduce it to half. Okay, so and multiply the half of the digits. Now A1 is not representing one digit. A1 is representing half of the digits. Is that clear? Multiply by 10 raised power n by 2 plus the remaining half digits. Same is the case for B number. The B number will be splitted into half digits number, and the unit portion will be added to the product of the tens number into 10 raised power n by 2. Did you understand this thing? So this is how we can rewrite any number of digits into a formula in which the problem size is being reduced by some factor. It is dividing the subproblem to the smaller one. Is that clear? And similarly, if you multiply these two terms, then your formula will look like A1 into B1 into 10 raised power n, A1 into B0 plus A0 into B1 into 10 raised power n by 2 plus A0 into B0. So this means for every recursive call, the given numbers will be divided into a number having half of the digits. Is that clear? So this approach is called divide and conquer approach. Is that clear? And again, the same expression can be rewritten as A1 into B1. This is the same formula, but now in two-digit formula, A1 is the complete digit, whereas A1 is the half group of the digits of the original number. Similarly, B1 is the collection of the half digits of the second number, and so on. So if you calculate in every iteration, how many multiplication do you need? You need 3 multiplications. Is that clear? And this division will stop when every digit will have only one number. Every number has one digit. Is it clear? So if you want to calculate the integer multiplication using divide and conquer, you have to memorize this formula. C2 into 10 raised power n plus C1 into 10 raised power n by 2 plus C0. And what is the C2, C1 and C0? That will be calculated A1 into B1, A0 into B0, and C1 will be calculated using this formula. Is that clear? So if you write a reference for this function and to calculate the number of multiplication, so you can see for every iteration we are reducing the problem with the half of the portion, and in every recursive call you have to make 3 multiplication. So the recurrence will look like 3mn will be equal to 3mn by 2. Is that clear? You need 3 multiplication for every recursive call, and with every recursive call, problem size will be reduced to half of the elements. Is it clear? So if you solve this recurrence using backward substitution, so you can solve it and you will at the end you will get the answer, which is equal to n raised power 1.585. What was the original efficiency of traditional multiplications having n digits? That was n square. Is that clear? So efficiency is improved. Also, it is not, although it is not a significant improvement, but your efficiency is improved little bit. Is that clear? So this is a exercise for you, that you have to rewrite the recurrence for the same process in which you have to calculate the number of additions and subtraction. Okay, and the recurrence is given and you have to solve only that recurrence. Is that clear? So find the efficiency of algorithm including all operation, multiplication, addition and subtraction. Recurrence is given and you have to only solve this recurrence. Similar kind of concept can be used for matrix multiplication. If you have to multiply the matrix, the standard way is that the number of columns of first matrix must be equal to the number of rows of second matrix. This is called compatibility condition for matrix multiplication. And if you multiply these matrices, first row will be multiplied by first column, then first row with the second column, then second row with the first column, and the second row with the second column. And this is how you can multiply the matrix. And this is the standard algorithm for multiplying the matrices. And looking at this matrix, can you guess what will be the efficiency of this algorithm? It will be n cube. Okay. On the same approach as we have discussed previously, this matrix multiplication can be multiplied using divide and conquer approach, and this multiplication is called Starson matrix multiplication. And they have also devised these resultant values by using this formula, m1 plus m4 minus m5 plus m7. You have to memorize these relations. Okay. M2 plus M4, and this entry can be calculated by M1 plus M3 minus M2 plus M6. You have to memorize, there is no way out. Okay, and what is these M1, M2, M3, M4 and M7? They are given here with the context of the digit value in the number. Here we are again multiplying the numbers in the matrices using divide and conquer approach. So here you can see how many multiplication you required to calculate the matrix multiplication. 1, 2, 3, 4, 5, 6 and 7. Is that clear? You need 7 multiplication. Is it clear? So for every recursive call you have to make 7 multiplication, and if we write the recurrence on this formula, every number of multiplication will be calculated by 7 into m of n minus n by 2, because after every multiplication the problem size of the in term of the digits of a number will be reduced by a factor of 2. So if you if you solve it by backward substitution, you can again see the result is n raised by 2.807. What was the efficiency of multiplying the matrices in a standard form? It was n cube, and you can see the result is improved, although it is not very significantly improved, but you have a improved result, n raised by 2.8. That's why I was saying that these matrices, these examples are using divide and conquer approach, but they are not improving the result very significantly. Similarly, one exercise is given related to the Starson matrix multiplication to calculate the efficiency of the algorithm on the basis of all operations. So if you see the formula, total number of operation other than the multiplication, they are 18. Okay. So this will be the your recurrence relation, and you can try to solve it and see what could be the running time. Do you remember the problem of closest pair problem? You have solved it using the brute force technique. Do you remember that? Anyone can explain what was that technique to solve to determine the closest pair of points in a two-dimensional Cartesian plane? The brute force technique was pick one point and compare it with all other points one by one and calculate the Euclidean distance. And after calculating all possible distance, whatever the value is the smallest, that will be your answer. So, and its efficiency was theta of n square. The same problem can be solved using divide and conquer approach. What is that divide and conquer approach? That you will not solve those points and this problem at once. You will split the points into two portions. Okay, you will divide it into half of the elements. Half of the element will be on the left side, half of the element will be on the almost on the right side, and this division process will continue until you reach to the 2 points which are considered as the smallest distance. Okay, so divide the point, given into two subset P1 and PL and PR. PL means points on the left side, points on the right side, by a vertical line x equal to m. This is the slope of that line. That will be a vertical line. Okay. And after that, you will find the shortest distance on the right side and shortest distance on the left side. And obviously you have to recursively divide, keep on dividing and then combining the result, as we have done for the merge sort. Remember the merge sort algorithm? This will have the similar kind of pattern. So when you are calculating this distance, smaller on the left side, smallest on the right side, which points will be the closest? Then you have to compare these two distances with each other. Whichever the distance is smaller, that will be considered the closest or not. You understand this process? The question is that we have divided the problem into two groups, left and right, okay? And we will keep on dividing it. And at the second last step, you have calculated the smallest, closest points from right, which is dr, and you have identified 2 points which are closest to each other on the left group, which is represented by dl. Now if you have to answer which 2 points are the closest one, what you will do? You will compare dl with dr. Whichever the value is smallest, that will be your answer or not? But what will happen if this point which is on the left side is the closest to a point which is on the right side? The distance between these 2 points is smaller than both of them. Then what you have to do? It means just comparing dl with dr will not give you an answer. Okay, is that clear? So after calculating the smallest distance in the right and in the left, what you have to do? You have to draw a rectangle along with this line, the middle line. Okay, that depends on the smallest distance. Okay, and keep on calculating the points which are not lying on the boundary. They are actually closer to the point from the distance which you have already calculated. Is that clear? So this is the third step. After calculating the minimum one, what you have to do, we can limit our attention to the points in the symmetric vertical strip as of which 2D as possible closest pair. So if the distance of this point and any other point within that rectangle, so you have to calculate the points which are coming inside this rectangle, and that will be the closest one. And you have to scan this complete strip. After that you will find the smallest one. Is it clear? This point is clear? So you have to scan this strip completely, and then you can decide which 2 points are the closest one. And in this approach, we are using divide and conquer because we are dividing the complete points into 2 groups, left and right, and in the same way we will keep on searching the closest points. So this is the formal algorithm to find the closest pair. This algorithm is a recursive algorithm or iterative algorithm? Mazhar, I could not understand. It is a recursive because we are calling efficient closest pair within their definition. And as I have told you, this is very similar approach as you have seen in merge sort. So the recurrence will be very similar to the merge sort. That will be 2Tn by 2 plus theta of n. And you know the running time will be n log n, which is way better than n square. Is that clear? Similarly, you have already solved the problem of convex hull. Remember that? In which you have to figure out the point on the boundary, extreme points on the boundaries. Okay, that problem can also be solved using divide and conquer approach. So what is the way to calculate the solve the convex hull problem? You will draw a line segment which can lie on a boundary. So if you draw a line and all points come on either side, then it is called those points are called, they are on the boundary line. Okay, so how you will solve it? You will keep on drawing the line, combining 2 points and determining whether the other points are on the same side or on the different side. So that approach, the running time was O of n cube. These were the number of distinct pairs, n into n minus 1 divided by 2, and number of points to be processed will be n minus 2, and the result was O of n cube. So what is the approach for divide and conquer? First of all, you have to sort the points with respect to x coordinate and identify the extreme point with respect to x. That can be easily determined. Okay. Extreme points you have determined, for example, P1 and P2, which are the leftmost or the rightmost. When you have sorted the points with respect to x coordinate, you can easily identify the extreme points, minimum x and the maximum x. Is that clear? Whatever the extreme points you have determined, join them together and they will form a line, and then determine the point which is the farthest most from this line and draw the triangle. See the diagram, then it will be more clear. We have identified the extreme point P1 and P2, and then we have determined an extreme point with respect to this line. Okay, for example, this is the farthest point from this line. Then you have to join them together. If you join, it will make a triangle. All points which are lying within that triangle, they cannot be boundary points. Is that clear? And then you will be left with only the points which are either upper of right side or it is upper side of the left side. Is that clear? And same work will be repeated for lower portion. Is it clear? And this is how you will keep on extending your search, and these points will be considered as an extreme point, boundary points. Similarly, again you will find the extreme points from here and the maximum distance point. Is that clear? In this way you can keep on expanding one side and the other sides, and you can find the farthest point as the boundary point. Is it clear? So this is called divide and conquer approach, and its running time, worst running time will be n square, which is better than n cube. So the difference between the brute force technique of solving the convex hull problem and divide and conquer approach is clear or not? In brute force technique, you are joining 2 points, every 2 points are joined, and then you will see whether all other points are lying on one side or not. And that those points will be considered as the boundary points. But in quick hull problem, you will sort the data on the one of the coordinate, for example x coordinate, and then you will figure out the extreme points, leftmost and rightmost point of that domain, and join them together. When you join those lines, the points will be divided into 2 groups, upper half and the lower half, and then you will find the extreme point, extreme distance point from this line, and it will form a triangle. All points which are lying inside the triangle, they will be ignored, and only points which are lying outside that triangle, they will be considered, and you will again make the extreme points, and you will find the boundary points for for given set of points. Is that clear? So we will stop here. Inshallah, we will continue with the next topic on Thursday. If you have any question about these algorithms, you can ask me. For these algorithms, if I told you with respect to the exam point of view, these algorithms are not really traceable with the data set for exam question, but at least you should memorize the efficiency as well as the recurrences of these algorithms. Is that clear? And others, you have to, you should memorize the